Hello all! Welcome back to Contemporary Software Development at Portland State University. In the first part of this slide deck, we learned about the Java Programming Platform's APIs for representing and formatting dates. If you haven't checked out that video yet, I encourage you to do so. In this screencast, we'll continue our discussion of working with dates and text with a focus on the formatting options enabled by the variable length parameters language feature. Let's get going. Many people became accustomed to formatting text using a facility like printf from the C programming language. With printf, the programmer specifies a string that represents the format of the data and then provides additional arguments, which is the data to be formatted. The Java API has a similar facility, and it relies on a language syntax that supports a variable number of arguments to a method call. Before this feature was introduced to the language, methods had to be overloaded to take 1, 2, 3, etc. arguments, or you had to pass an array. This was awkward and made it difficult to represent something like printf. You can declare that a method takes a variable number of arguments by using a special keyword in the language, which is 3 dots. It's like an ellipses. And that indicates that the parameter can take multiple arguments. In the implementation of a method, the var arg is treated like an array. You can access its length, and it is 0 indexed. Note though that a method can only have one variable length argument in its list, and it has to be the last one. A great example of var args is the arrays.asList method. This is a static method of the arrays class that will take an arbitrary number of objects and place them in a list. Here's an example of using a method with a variable length argument list. We have a static method called printSum that takes a string, which is the header to print out, before ultimately printing out the sum of a variable number of ints that are passed into this method. So the first thing that this method does is it computes the sum of all of the ints. And again, the language syntax for working with a var arg looks just like an array. And you can iterate over it just like you can for an array. So you can use the enhanced for loop to say, hey, for each int I in my int argument, add it to the sum. Then we print out the header, and then we print out the sum. So there in the main method, we can see how this method is invoked. We can call printSum with the header of 1 plus 2 plus 3 equals, with the arguments 1, 2, and 3. And then we invoke printSum 2 more times, but with different numbers of arguments. And the second time, it's 1, 2, 3, 4, 5, and the third time, it's 2, 4, 6, 8. The language is able to handle this because when we declared the second parameter to the printSum method, it's int ... which means that's a variable length argument. In the first part of this screencast, we talked a lot about date formatting. But Java has facilities for formatting other kinds of objects too. Now you could use a string builder to format objects, or you could use message format, which is kind of a low-level API because it does have a format method. However, there are also APIs that leverage the variable length argument list language feature to provide functionality that is akin to the printf function in C or the scanf function in C for parsing character data into an object. The PrintStream class has a printf method which provides a format string and a variable length argument for the objects to be formatted. And recall that system.out and system.err are instances of PrintStream. Printf and other methods like it are implemented internally using the Java util formatter class. If you want to do some lower level formatting or really want to understand how all this works, you can check out that class. Formatter is the thing that knows how to convert primitive types, strings, calendars, etc. into strings of different formats. While the printf method of printstream will format some objects and write it to the underlying stream, if you want to format objects into a string that you can use someplace else, you use the string.format method. We'll take a look at the details shortly, but the formats that are supported by the Java Formatting API is a superset of what you would see in most C implementations. However, there are some additional features that make more sense to the Java language and the Java programmers. So for instance, with Java, if you attempt to convert an incompatible type, say format a calendar object as an int, you'll get a runtime exception. So here's the general form of the format strings. And again, if you are familiar with cprintf, this should look like something you've seen before. When you want to format a piece of data, your format string contains a percent and ultimately some character that represents the type of data that you want to format. You can precede it with information about how precise you want it to be, how wide you want it to be, some additional flags, and then which number argument it is. Let's take a look at some of the conversion characters that are available in these text formatting APIs. If you want to format a Boolean object, either a little b Boolean or a big B Boolean, you would say %b. Similarly, %d for a decimal integer, or %x for integer in hexadecimal format. You can use %e, %f, %g, and %a for floating point numbers, and each one of those varies in terms of the number of significant digits and exponents. You can also use conversion characters like %h to get the hash code of an object, or %t to get some aspect of the date and time. You can say %% for the literal character percent in your format string, and %n for new line, which will be the platform-specific line separator. The text formatting APIs in Java provide facilities for formatting dates and times. This is really quite convenient when you don't necessarily want to use the java.time APIs. If you're sitting there just doing text formatting using sprintf or string.format, this makes it nice and convenient. And it's similar to the strftime function call from POSIX. And the way this works is that you use the t conversion character followed by one of these specific date-time conversion characters. So you can say %t big H, which will return the hour of the day from 0 to 23. Similarly, you can get the minute with %t big M, and the number of seconds with %t_s. You can also format information about the date, again with %t followed by capital B for the full month, like capital J January. You can also get short months and similar formatting for the day of the week, the year, and the day of the month. Now the % format can also have flags that are applied to it. And this allows you to do things like have the number or date be left justified in all uppercase. And for numbers, you can specify whether or not there is a leading space, whether or not it's zero padded, or if the grouping separator is present. Here's an example of using format strings. We leverage the printf method of the print stream that represents standard output to format various pieces of information, in particular the current date and time. So if we call printf and provide the format string %s %n and then the parameter hello world, that'll print out hello world followed by a new line, because the object hello world is formatted using the %s format. We'll get a calendar that represents the current date and time, and we'll print out information about the date using %tm for month /%td /%ty followed by %n for new line. And because we're formatting 3 aspects of the date, we need to pass in the calendar object 3 times to printf. Similarly, we format some information about the current time. Next is an example of formatting numbers. So here we say %f for floating point, and then we say / for divide, and then %2f saying that we want to format a floating point number with 2 decimal places. And then it'll equal, well, some other double formatted as a floating point. And we pass in the arguments 2.0, 3.0, and then 2 divided by 3. Inside that for loop, we print out some numbers formatted in a fixed width column of 5 characters. So we've got 3 ints. They're all formatted as strings with a width of 5 spaces in each column. Finally, we look at left and right justified text on the left side of a column that's 10 characters wide. And then by default, the string right is formatted on the right side. When we run this program, we see the following. We see hello world, which is just the string hello world formatted with %s%n. We see information about the current date and time. We see doubles formatted as floating point numbers. By default, 2.0 has 6 digits of precision in its decimal. And when we divide it by 3.00, the reason there's only 2 zeros is because that's what we specified in the format. We printed out some ints that are each within a column of fixed width of 5 characters. And finally, we have our left and right justified text. So that concludes our tour of Java's facilities for working with dates and text. As I hope you saw, there are several really robust mechanisms for working with numbers, with times, and with dates. There are some legacy APIs like the Java Util date, calendar, and date format classes that get the job done, and you'll probably see that in a lot of older code. But there are some deficiencies that then motivated the authors of the Java APIs to introduce the java.time packages. The classes in these packages provide full support for a number of different date and time capabilities. As we saw, the objects in those APIs are largely immutable, and therefore they're thread safe. We also saw how the variable length argument language feature enables APIs like printf that provide familiar and overall pretty easy to use text formatting. And that's it. Thank you for exploring Java's facilities for working with dates and text. There's a lot of power in these APIs that you can leverage far beyond the work that you do as part of contemporary software development here at Portland State University.